I've become like the Ross Perot recently of the data infrastructure. I was asked today to join Jeff in talking about how we put things together. Unfortunately, I have no disclosures. I'm going to talk about background, a little bit about some examples for how to get the data, how the data is put together, a little bit about how we do things at Stanford, how we're organized to help you get the data for all your models, if I may. This is sort of a standard schema. How many of you are EPIC people here? All right, good. Then I don't feel absolutely awful about using a brand name. EPIC is only about a third of the market, but it's overrepresented in academic emergency departments. It's my shop. The concepts are the same no matter what you use. Other places don't have the really cool kind of names that EPIC throws out, like Caboodle. Don't quite get that. All right, so we all start with hyperspace. This is our EHR where the data comes in. And then it moves over into our more of an operational area. These are the real-time cache in Chronicles. Things are coming in here, out here. It's all organized, which is really great for patient care, but it's no good for analytics. Once you have some normalization, it goes into Clarity. And this is where a lot of the operations that Jeff spoke about is going to be coming out. And this is going to be good for operationals data, and then if you could mix it with some other non-EHR data, you get into the Caboodle. We have the star schema for how things are related to it. At Stanford, we actually, this is not the things aren't quite right as far as the way they're set up here, but that's fine. You mix some other things. At Stanford, we don't use the Caboodle so much. We actually went to a consultant. We had our enterprise data warehouse made by Catalyst, and we put things into a separate database. It's a little, it's very nice for keeping large amounts of data well organized in order to get things in and out, to pull the data that you're going to need in order to train your models. In addition, we have to our EDW, we have that in the center of a very poorly organized data lake where there's all types of information that are in there. We have our information that comes in from radiology, from pathology, from HL7 feeds from all over the place in the data lake, which will be useful, although harder to get when it's in a less organized data lake model. Now, it's not just about getting data out in order to train your models. Sometimes you're going to want to be interactive with your EHR. Let's be honest, EHR is very good for patient care. It kind of can't think all that much. And sometimes you're going to need brain power in order to think, and you're going to want to put your model in some sort of cognitive computing layer. AWS, IBM has their Azure product, and you want to have something to a place to think about things. Epic now has something called Nebula, which is just their cloud computing software, plus, as Jeff said, this proprietary API to take things in and out. If you don't want to spend the time for the licensing on that, you can just use your HL7 or Fire to take things in and out. Computing layer, think about it, and jam it back into Chronicles, back into hyperspace. So you could not only think about things, but direct your clinicians to do things different in their EHR. You could also send things over into external applications if you want to give people information on their iPhones to help them make decisions. It's nice to be in a separate layer here because you get to keep some of your algorithms and research your own and not have it all live in a proprietary system like your EHR. I'm going to run through a few examples here. The cases have been changed, but the names have been kept the same in order to protect the innocent. These names have absolutely no relationship to people in the room like Maya. It's just a coincidence that your name happens to be up there. Another person with the same name. Yeah. All right, so Dev is doing a project, okay? He's videotaping his patients, and then he's running through an image recognition program that he's working on, and he wants to relate this to outcomes. Who's being admitted, what kind of procedures do they have, how likely are they to survive? Now, Dev is trying to train his algorithm. Where's he going to get the data for this? Where would be the most appropriate place? Probably like your EDW would be the most important place. He's going to need things like were they admitted, how long were they in the emergency department, what sort of procedures they have. All this is going to be highly organized in a relational database in the EDW. Maya, on the other hand, already has an algorithm that she's working with. But what she wants to do is she wants to take information from your triage, maybe some demographics. She wants to know what your chief complaint is. She wants to put this into a model. She wants to think about it for a little bit, and then she wants to stick something back into Epic, into hyperspace, to say, oh, hold it, their chest pain, they're in the ED for chest pain, they're 87 years old, maybe I should be getting an ECG on the patient, and put in an order for an ECG. So Maya is going to want to start over here in Chronicles, get the information out in real time as quick as possible, put it into some sort of an analytics kind of computing layer, and then put the data back into Chronicle, back into hyperspace, and trigger a BPA, which is going to tell the clinician, hey, now's the time that you're going to want to get an ECG on the patient. So different needs, different parts of the algorithm. Going to go through a little bit about Stanford, about our models, how we organize things. Just as an example, we have our Stride tools where we're taking information, we're out of clarity, put it into an Oracle database. From here, you've got two ways that you can get this information. They have a very nice service, which is an anonymous patient cohort determining tool. So if you come on over and you say, somebody came to me once and they had this great model on, who to test for HIV, given the background and the history. They wanted to know how many people in Stanford Emergency Department had HIV in the year 2000. So we put it into Stride. We went through the anonymous cohort tool, and actually the numbers were fairly small. It was not enough to train the model, so we had to stop that program, and really surprised me. If there was enough, you could file an IRB, your data privacy attestation, and then you get unanonymized data. You get the data points that you're looking for. You can go on with your model. The STAR registry is more of a data lake. So in addition to getting the well-organized Clarity data, like I was saying, you're bringing in all these other things from pathology and radiology and PowerScribe and HL7 feeds from EMS, ECGs, monitor data, everything sort of floating around in this lake. And this, you have the ability to either do queries to in an anonymous fashion, or once you have your IRB, to get the actual patient data. Most people these days are at Stanford are using it in the OMOP. Jeff spoke a little bit about this. This is a wonderful way to get data if you're doing a multi-institutional study. As Jeff was saying, that if you have the same analytics, the same search, now that if you have OMAP, the common data model, you're able to get the similar results. We have standard definitions for your encounters, your meds, your procedures. You lose something here. I don't know about your hospital, but my hospital, we have a lot of custom data. Everybody wants to have their own data in there, and if it doesn't fit into the common model, I'm sorry, it just might not be there, and it'll certainly be difficult to retrieve. So the advantages is it's great for multi-institutional. The disadvantages you lose some custom stuff. I'm sorry. Wide adoption, private, public, over 90 hospitals, but more our types of hospitals, if you're part of SAEM, are using this. It's a good thing to have. Pulling this all together for research data, you got a great idea. You do an anonymous cohort discovery. You decide if there's enough N. If there's not enough N, forget it. If there is, you get your IRB, your data, your IRB approval, your data privacy attestation. You go on over to the proper database for you, whether you're going to want the STAR OMOP, the Stride database, and then you can get a query. You can get this into a spreadsheet. For people who like larger databases, it's much easier to keep it in the Google Cloud platform, and then you could take your Jupyter notebook or your R and your analytics and work with it while it's in the cloud. All That's the research side of the house. We also have the production side of the house in Stanford. This is our Clarity and our enterprise data warehouse, which is used more for our clinical side. Since people usually want clinical data, there's a lot of things in here of use. We're working on a project now. Don't need to get too much into it, but we have a SAP business intelligence software that we put on top of an edge, and we could just get out very large amounts of data, and we could also schedule this to pull it out every week, month, or year, put it into your cloud, and let your model assess it as necessary. Now, I break it down between operations and productions. It's not this simple. I requested to borrow this slide from Nigam Shah, a colleague of mine who's actually also doing work in deterioration and trying to figure out who needs an inpatient consultation for palliative care. To get the right resources to the patient, to provide the comfort and support they need, and to get them out of our Vizient numbers so we look better on paper. I didn't say that in public. Oh gosh, we're being recorded. It shows you the balance between the research and the production side. He has a wonderful model for predicting who's going to need a palliative care. All right, so he starts with the STRIDE database, and he's going to train his model here, and he's going to make the best model that he can. But now, once you have the model, you have to go back and forth now from the research side of the house to production, and this is getting moved over to our production, to our Clarity on the clinical side. That's going to take the data, put it back into Chronicles, back into hyperspace, and if the patient needs it, it will trigger a pop-up for the doctors in order to get an alert to get a consult for palliative care, and that's wonderful. And it's nice because we know that our Clarity from the clinical side feeds back into the research side, and he's able to retrain his model every day and get the updates such that over time his model is getting better and better in training itself. So this is kind of complex. You've got two different databases, one on the research, one on the operational side, and it provides support for the AI model for prediction of who needs palliative care. And I'm going to take a moment to talk about my latest project that I'm working on. This is the subject area MART for our emergency department. You have the EDW, it's big, it's got a lot of things. Everybody in this room is an emergency provider. We mostly only care about people who are coming through the emergency department, and we really understand what's in the ED data. The clinical data warehouse has a lot of things in it that we don't know if they actually mean real life, and there's a lot of things about the inpatient, outpatient world that I don't use and I don't understand very well. So we're trying to make a subject area MART just for the emergency department, well curated, well validated, define a lot of our metrics in a standard way, so anybody who goes in and builds a model based upon let's say length of stay, they're doing door to depart and maybe not door to disposition, making very standard metrics for it. It can be searched through SQL, just as our main clinical data warehouse is. And then I put another layer on top of this, and there's two different concepts that I'm introducing in this slide. If you have the time, the ability to put another business intelligence layer on top of it, we put Tableau on it. It's just easier to get the data out of the EDW once you have Tableau on it, and it makes really pretty pictures, and it's easier to share on Tableau. Yeah, the pictures are important. They are. I'm sorry. So you can get the data through your SQL searches, or you could put it through your Tableau and be able to share it on a server. Let's put Tableau aside for a moment. If you have the resources available to do a subject area MART, it has well manicured data. It's all verified. It's ED focused. This is a nice way to define things up front. It's a higher level for emergency department metrics. You can put extra layers to get things out on an automated way, and it's so simple because it updates itself at whatever sort of routine that you bring it in. The problem with having a well manicured, well validated data set for the emergency department is somebody has to go through and validate it and manicure it. Whoever that poor SAP is, I feel sorry for them, because making all the numbers in there actually Yeah, no, that's me who actually, Christian, we're on the same committees and we do it together, but at the moment I'm doing a lot of the validation and making all the numbers match things in real life has been very, very difficult. So it takes time and effort to build these tools, but they're coming together now and we're getting there. So it's about getting the data together, all right? It's about building the infrastructure behind it, understanding where the data moves in the right part of the plumbing that you need to get your data out and get your information back in order to help your clinicians with the algorithms that you're making. It's about having a layer on top, your BI or BA software, in order to learn, or your SQL to start sucking this data out in order to train your algorithms, in order to build your models. And all this is just going, to be the cup that you want filled with your data. I want to thank you very much. I think that was about 13 minutes. We spoke a little bit about the structure of the data, how to get things out, where to get it in, where along the best path you could think of in order to remove your data. And I want to thank Andra, Christian, and Nigam for letting me steal some of his slides. ¿Tienes preguntas, señoras y señores? Sí.
How do you do intake for the SAM when everybody wants a piece of the SAM?
How do I take intakes for like how to, if people request it?
Like, can we add this to it? Everybody wants their added little chunk. How do you govern that?
Yeah. Actually, we've got 3 members of our governing committee right here. And we had dinner last night with the person who has made some of the biggest requests. David, he wanted like all of vital signs in there for one of his projects. And there's a lot of vital signs taken in an emergency department and trying to pull, I mean, it's sort of, so we've got a request form for getting data out, and that's a well trodden path that we have. How you're going to request, and whether you have the data attestation and IRB and everything's together. And then if some data is not in there, we sit down and we discuss whether or not we're going to fill this. We speak to our architect in order to find out how that is going to affect the performance of the system. Because the bigger it's getting, the slower things are getting, particularly as we have different things related to each other, it really affects performance. And if he says it's going to slow down the system, we reject it. And then if it doesn't, we think about how much time our architect has to put towards this, because we only have a slice of it. It takes money to build this. If he's got the time, what other projects are happening? Maybe that's not the right way to say it, but it's a very practical piece. No.
This is relatively new for us, and the primary interest for getting data out has been from our researchers. I think as people see that we have data that's meaningful to us, the demand will go up, and we're sort of anticipating that, and sort of what that governance looks like is a challenge that will come. But I think where we've kept things now is the SAM needs to stay functional, and if we're adding so much that elements are used infrequently that are slowing the system down, those are ones that we would triage out. But we haven't had to make the hard decisions to say no to anyone just yet. Silently, we give them what they're looking for, but like on the back end, we haven't had to say it's not for you next time. We haven't had to say it out loud.
Yeah.
Is your architect in the department, or is it from like the bigger institutional?
That's a complicated question, and we're changing it at the moment. We're actually renting somebody from the larger hospital because we don't want to be too separate. We want to make sure that they know about the EDW, both on the operations side and on the research side, and they've got a larger group to borrow from. So we don't want to isolate them, but we want to own them so we could prioritize what they do. So we just went in and we said, hey, do you have somebody we could like buy their time? And they're like, hey, do you have money? Stanford works that way. Damn it, I've got to turn this off. And so we're renting somebody, and we've been happy, and we're looking for a new person. If you have anybody,
I'm sure I could send that from Montreal.
yeah.
So related to that, practically, who rents? So meaning like who's funding? Like how do you guys fund all of this effort? This is we run a team in when we have people come and ask for resources from the things that we've built, it becomes a little bit challenging, right? So who is funding these?
So my thanks, I had three people I thanked. The first is one of my colleagues, Christian, who was sitting here as I went over and over the slides over the last couple days. The other one was Nigam Shah, who I stole some of the slides. And the third one was Andra, who's our chair. And I'm thanking her because she has been very generous with providing some of the money for building the infrastructure for our research groups and hiring intelligent AI people like the two people that you see sitting in front of you. So she's hiring the right people, and she needed to make sure that there was data for them to work with. And so she is paying for. Actually, I don't think she realized she's paying for building the infrastructure. I think she thought she was paying for someone to do the SQL searches to get the data out of the EDW. And then what time was on the side, I sort of redirected him, and it's all working well.
And do your databases, this is like just a practical question, are they governed under like a QI mechanism, or are they governed by a research mechanism? Because it sounds like you're using for both things, right? So,
Yeah, the data structure is sort of just, it's essentially an EM relevant flow from the EDW.
Yeah.
But in terms of how people get data out, we do have two streams of consideration, where the thresholds for rigor before we approve the request are different if it's research versus operational. On the operational side, these are folks who already have access to the data for the purpose of improving care delivery. And so sort of what the data is used for is a little bit less stringent than folks who are making a research data request, where we have to acknowledge all research compliance data issues, which gets a little bit more rigorous. And a lot of our learning curve as a group has been a matter of how do we do that in tandem with the institution and federal guidelines, which is tricky. But we really put the burden of checking all the boxes on the researcher to then provide to us before we build the request, whereas we don't have that same layer for the clinical operations request.
And the clinical data models that we follow and the rules for architecture are production-based, not research-based. So we're not using the OMOP. We're using something much more similar to our clinical data warehouse. Yeah, so I didn't want to. So we are using Health Catalyst. Stanford has a long relationship with Health Catalyst. We like the way they set up their EDWs. The person who we're using now from the hospital, actually the hospital got them from Health Catalyst, and then we're borrowing them from the hospital. So Health Catalyst set up our EDW. It's providing our SAEM, and it's our searches. They're a consulting group that. I just like the way they set up it's sort of not quite an EDW, it's not quite a data lake. They sort of have this hybrid model, which we found very useful at our hospital, and they bring in talented folks. And that, I don't know if for my life, I read a lot of Brett James, and I'm sort of a fan of what he did in Utah at Intermountain, and he's part of their group. And so it's set up in order to help make institutional change by using their data. And it's not just a matter of getting the data in front of you. So I like the way they work.